As you can see behind me, Revolutionizing blockchain, an introduction to Nexa. They're going to tell you now, you're going to be treated now with their perspective on all of this and helping you make sense of things in a better way as well. I'm intrigued, again, as much as you are, really, to hear how this is going to unfold. Please welcome right now on stage Mr. Andrew Stone.
Thanks. So I'm actually the lead developer of Bitcoin Unlimited. My name is Andrew Stone. I'm not a speaker generally, so please forgive me for this and any microphone problems like that. My mission is to create sound money, cryptocurrency, usable by everyone every single day. I think that's a really important goal for cryptocurrency. So in service of that goal, I thought to myself, what do I want you guys to come away with from this conference? And I think I would really like you to understand maybe what blockchains actually are. And I'm not sure if people, either as a beginner, maybe you're asking this question, and maybe as someone who has been around for a while, you may have gotten yourself so involved in your own project that you've forgotten maybe what the larger context is. Have you ever had to sit down for dinner and someone says, well, what is this anyway? And you find that you can barely answer the question. I hear people laughing, so I guess that might be the case, right? Because it's this large and complicated thing, right? But has anyone ever tried to boil it down to its pure essence, right? So I'm going to try and do that for you, and then I'll explain why, given those precepts, we built Nexa. Okay. So basically, in a nutshell, I believe that blockchains are fundamentally a language, and they're a language of ownership. And to make an even more profound statement, I would argue they're the first language of ownership. And now you might say, well, what about contracts, right? When I bought my house or whatever, I had to sign this long contract, right? But these contracts in other natural language styles of speech, they embody concepts, right? So there's a concept of ownership in a natural language and in a contract, but it doesn't embody ownership itself, right? This is a very subtle but important point. And I think to understand the point more, think about a fantasy movie that you saw where someone makes a magic spell, right? And they say I want light to appear, right? And then light does actually appear. So in a magic world, the language actually embodies the thing, right? I said light and light appeared. But in the real world, if I say light, nothing happens, right? Because I have this concept. So contracts, in contracts, you write a bunch of words on a piece of paper, and if you convince people that those words have some truth and validity, then maybe they'll actually adhere to them, right? But in a blockchain, it's very different. It actually embodies ownership in a sense that it doesn't matter if anyone pays attention to the chain or not, right? Only you have the power to make statements about transfer on the blockchain. And the blockchain itself enforces that. And even more interestingly, in some strange magic way, you cannot make a lie on most blockchains. Some of them, like Ethereum, can say, oh, you lied about this, so give me your transaction fee anyway, but it's still a lie, right? But this essential issue remains that if you attempt to make a lie on the blockchain, the chain itself, the language itself, rejects that statement, right? And I've not heard of any other language that exists that has those features. Okay, so given that sense, what did we do to sort of try and produce this language, right? And so you might ask yourself, well, what makes the best language, right? And there's some issues like expressivity, succinctness, and then finally stuff like, which in blockchains we call like performance or scalability, but basically like obvious things for languages is you have to have multiple people have to be able to carry on separate conversations, right? And you have to have lots of conversations happening at the same time. And in natural languages, that's taken for granted. But obviously, in blockchains, we're focused on that a lot. So Nexa is our construction of what I think is the best language for the actual embodiment of ownership. It's UTXO family, which has some interesting parallelization possibilities compared to EVM family stuff. It essentially allows everyone sort of independently have conversations. That's why we chose that. Proof of work. Why? Because, and this is obviously a matter of great debate in the industry, but you're putting actual energy behind the statements. So if someone wants to undo your statement and maybe make it disappear, it takes energy, it takes money to do that. Whereas in proof of stake, as we kind of learned with the possibility of the recent Ethereum hack being unrolled, what it really took was a bunch of people talking to each other and deciding to make that happen. And so, to some degree, proof of work and proof of stake kind of undermines the power of the language because it doesn't capture possession, ownership quite as strongly, I believe, as proof of work languages. Okay. And of course, we want everyone to be able to talk independently without permission and so forth. So I think lots of blockchains have these other features. We have 2-minute block time, so we want to be able to talk a lot quicker. But at the same time, we have this idea of double spend proofs, which basically says, hey, if you're trying to lie, we're going to discover that right away and prevent the network from saying it. Oh, and finally, if a blockchain is a record of ownership, we don't want to be able to cheat your ownership by suddenly what you thought you had something special, but it turns out, there's 100 billion million of them that you didn't previously know about, right? So we're a fairly launched coin. Okay, and then also, this is talking here, everyone knows the importance of tokens, but you'd be amazed, if you talk to a Bitcoiner, how they still think that a blockchain should only be about the native token, right? But if you look at this from a language perspective, you can understand how that's silly because languages have nouns, verbs, right? Nouns would be us. The verbs are the contracts, and the objects in a language, right, are the tokens, right? So I bought X, right? And so if you only have one object in your entire language, how effective of a language is that? Okay, and next, so we have so this creates some really interesting ideas. And one is that we can create a conversation that builds on itself. And so what this is it's called a multi-party interactive transaction. So basically what's happening here is I'm making a statement that says, hey, I'm going to offer some Nexa for a token, right? And then I sign that. So I make a positive statement that I'm willing to do that. And then without my further involvement, someone can complete this transaction by offering the token and taking the Nexa. And the key thing to think about here is and so that QR code there is, and if you use our wallet, you can scan that. And it doesn't get you to a website that then implements this in a centralized way, right? Those light and dark spots are the language that makes the offer that cannot be changed or reduced to actually trade some Nexa for that little picture. Yes. And that ultimately is how this is a language.
And I had it.
I'm running behind a little bit, so I just want to say, here's an example of what it looks like. And another thing is, compared to like EVM chains, you can't fake Nexa out just like that $1.4 billion hack did. We're not sure if it's a user interface problem or a contract problem, but in Nexa, the language specifically says this is exactly how the blockchain is going to change, and your phone wallet shows exactly what the changes are, right? So it's important not to serve the user interface right before you make the change. And the last slide was just like, thank you, but it appears to be gone. Someone must have hit the back button. So that's it. My time's over. Thank you guys for listening.
Yes.
Thank you so much, Andrew. So wonderful. Where we are next, and guess what?